Okay, now let's cook up for ourselves a small example. Let's say we will be entering numbers. Just give some example, like 1142 minus 3, 8 and 7, right? And then hit the Control D, end of file, right? And the moment this is created, we have a structure which links like this. Oh, by the way, in computer science, the null pointer is not written as null over there, but a diagonal in the box represents it. From here, it is accessed where it is something like this. So the first entered number goes into the very deep one. Of course, we will not read in all numbers first and then create structures. This is the most stupidest way to do it. Normally, you read the number and you create the first node and store in here the 11. So you have a start position that is made to point to the first element. Then you ask, is there a new number available, or did the guy hit the Control D, which stands for the no more number? Okay, if that is the case, and let's say 42 is entered, not end of file, then somewhere you create a new structure. You put in the 42, and oh, now very careful. If I take this pointer, if I change this pointer to point to this position, then how will I point from here to here? Oh, trouble. So I go the other way around. While start is pointing to this, I make a copy of start into here. So now two pointer fields point to the same position. Is this possible? Certainly yes. Several pointer values can be the same. No problem in this. And now I have the right to alter start and make start point to the new created. But for that purpose, I have to keep the new created somewhere. So, let's summarize what we are going to do. So, get new numbers. Is it Control D? A question. Yes, we will deal with this later. No, we go down to what? First of all, we need some place to store the value. So, do malloc. Do malloc. Then store the number that in the new malloc position, then comes to take it into the link, copy, start into news link field, copy news pointers into start. And then what? Then go and get a new number. What if he presses or she presses Ctrl D, then just return start. Return start. That is an iterative solution to the problem to construct this singly linked list from numerical input. Now, let's go step by step through the coding. First, I need the definition of the structure for this one. And let's do it the hardcore professional way. So, I have a structure. Since there is a self-reference in here, it must be named, let's call it what? Element. Structure element. It has some field that will hold the number. This number, 7a minus 3. It's an integer, so it's an integer field. Let's call it data. And a field which holds a pointer to structure element. So, a field that holds a structure element pointer which is named with something. Usually it's named as next or link. I'll name it leaf. Leaf. Any other field? No. This defines the structure. If I'm going to let it stay as it is, I will put over here a semicolon, but I will embed this into a type def. So here goes in a type def, the structure element, now a name for it. I name it with the same identifier element. But I don't stop over here, since start the new element, the new malloc. These fields are all pointers to elements. I give a new name to structure, pointer to a structure element, a new type, a pointer type, and a new name to it. I call it EP. EP. So EP is identical to structure element pointer. Here sits such a pointer. Here sits such a pointer. When I get something from malloc to get my hands on the subfields, I cast it to a structure element. Right? So from now on, instead of structure element pointer, I will be using EP. My function, which does this job, finally returns me the pointer to the last entered element. We call it the head. The head elements pointer. So whatever we name the function, read list for example, returns EP, a pointer to the structure element. Okay, now we said we will play hardcore professional. A hardcore professional doesn't stop over here. Immediately puts down the defines. Since I have done this so many times in teaching, I know that what will be flying around will be all structure element pointers, EPs. So I write down my subfield access methods by pointers, not the structure elements itself, but the pointers. So, to get my hands on the data, if a pointer is given, is by take the pointer, dereference it, go to the subfield data. But there is, since this appears so much in computing, for this purpose we have a special operator in C. P pointing to a structure, and I want to get my hands on the data subfield. This operator, the minus sign and the greater sign, without any space in between, is the subfield referencing operator. It is a very good and very professional way to put parentheses around the token, we call this the token, and the final result. Someday we will be talking about the benefit of this. So that is not professional, not knowing what's going on. That's a very professional approach to put parentheses around the token and the final result. And define link. P, the link of it. Yeah. And from now on, I will not refer to the structured subfields by the dot notation, no, always by these macros, data entry. It is customary in the professional world to put macros with argument or without argument, always in all capitals. Right? So you tell another programmer or yourself, looking at your own code maybe a couple of years later, that this is not a function, but it's a macro with argument. Okay. Now, let's start coding this algorithm into a function. A function needs a name. What shall be the name? Read list. So we have a read list function. Does it take any argument? No, sorry, nothing. So it's void. Does it return anything? Yes. It returns the pointer of the last added element. So the start of the linked list. So it is a pointer to an element. Pointer to an element has a new name, EP. So it returns EP. Careful, there is no asterisk sitting in. It is buried into the type def redefinition. Obviously, I need a variable that will hold the last added element while we are looping through here, the start. So, no discussion, I need a EP variable start. Also, I need a variable, a pointer variable, except start, for the very new created element. Let's call it also new. Okay. And let's start coding. This is a cycling through which has a console in there, very suitable for a while. Now, what I want to say is, while I have read an integer, I'm Now think of scanf. How can I do this? How can I tell whether a scanf managed to read a integer? Let's start, let's give it a try. Scanf read percentage %d. Oh, I need a place to read it in. You may think that, oh, the place is already there. No, it is not there. I haven't done the allocation yet. Do the allocation. No, I won't. I won't because maybe the guy hits a Control D and stops the entering of the list. So I need another variable. I need a variable for reading in an integer. Int, let's say, what? Value. Okay? Into value. Now, how can I make sure whether the value is read or not? Now comes into the scene something which we usually don't use. Scanf is a function actually. It returns a value and has a side effect of reading in a variable or more variables, but also it returns a value. The value tells us how many fields are read successfully. Here we have only one field, but it could have been in some other problem, something like this. Let's say LF, for example. And if this scanf would successfully read a decimal integer, a floating point, and a double correctly, then it would return 3. 1, 2, 3. Meaning I was able to read 3 subfields defined by this percentage signs. In my case, if I get something less than that, let's say 2, I will understand that this is that, and this is that, this is that, this is that. This may have some error. How could that be? I pressed some, instead of some floating point number digits, I pressed, let's say, A, B, C, some characters from the alphabet. It couldn't resolve it as a double numbers, but the way to tell me is I could read the first 2 fields, then there was a mistake. When an end of file Control D is hit, then scanf tells me this entrance by a -1 return value. So from here, if I get a -1, this means stop. He entered Control D. So, making use of this, I will continue this, provided that I read in from here something, and scanf tells me this event by returning a 1. The side effect is that value receives a proper read in decimal value. Okay, now I will be doing something in here, multiple stuff, so I open up a statement grouping, And now the next step. What does it say? Do the malloc. Do the malloc. Okay, let me do the malloc. Malloc. The size of what? Size of. If you say EP, you are in a deep pile of dot dot dot. EP is a pointer to the structure. I need the whole space for the structure. So either I will say structure element, or with the new naming, I drop the structure and call it simply element. And this will provide me a pointer. Do I have to typecast the pointer? Many books, extremely in a silly way, does this. No, you don't need to do the casting. Let the compiler do it for you. Just put it into a proper pointer variable. A pointer variable of EP type. We have already something like this. It will not go into start, it will go into new. New is this. Definitely there is no need to make here a typecasting. This returns a void pointer. This is a pointer of structure element pointer. The compiler does it for you. There is definitely no meaning in putting in here in something, a typecasting of EP or something like that. You don't need it. Please don't do it in your professional life, right? Okay, now what we have done is we have a start box, we have a new box, and in here we have put something like this. What is in here? All garbage. Yet what you get with malloc is full with garbage. Okay, so let's store what we have let in here. What we have let in sits in the value box. So store it. Data pointed by new, the subfield, receives a copy of value. Okay? Now this becomes 11. Then start receives new. But for the moment, as we said in 111, it is not a good idea to follow an algorithm from the start if it's an iterative algorithm. Just start somewhere in between. So let's assume for a second that we had something stored in start already. And we are at, let's say, -3. So this statement stored in the -3, nothing sitting in here, and here is already somehow these created, right? Now, these stages, very careful. What does it say? Store the number read into the new malloc. Yes, we did it. Copy start into news. Copy start into news link field. Okay, let's do that. Link pointed by new shall receive a copy of start. Okay, so here now, sorry. Start is pointing to this position. Now I'm also pointing to this position. Now it's time to change the value of start. So start shall be altered to point to this position. Start receives the value of new. New is pointing to this new malloc. Okay. Let's check it. Are we all okay? Start. Yes, -3 is in the loop. And now we are ready to read in the 8. And we go from here to here. So it's the end of the while. Lovely. At the very end, when I hit a Control D, scanf returns a -1 as an indication of the end of file. The while stops and comes to this point, and it's time for me to return. What will I return? I will return the start box. So return start. This completes my function definition. Does it? Does it? Didn't I do anything wrong? I made a mistake. I did it deliberately because I know very well that you will be doing it in your own programming as well. When you encode or create an iterative algorithm, you shall go somewhere in between. That is correct, as we did. But this also makes you missing some initializations. Therefore, this is not told in any book, right? That is just professional advice, right? After you have completed your coding, go and check your algorithm or your code for any local variable being used uninitialized. First of all, recall that start, new, and value do not have an initial value yet, and they are full with garbage. Okay, so which local variables do we have? We have the start, we have the new. Sorry. First of all, we will be using the value, so value, then the new, then the start. Now we go through the algorithm and look for their first usage, very first moment. Not somewhere in the middle, but the very first one. Now, take value, the first one. We go down, the first entrance of the read list, value is created in the activation record. A scanf may fill in the value, right? May fill in the value. So, if we are in this body, or the while, I know that something is red, and here I have a value, proper value read in. If I even not once enter the while, oh, then the value is a question mark. It's full with garbage. So I go down to while. Do I use in here the value of value? No, I don't use it. So there is no trouble. No problem with value. Value is okay. Now take new. We come from here, new is created. Here we don't do anything with new. Somehow we find ourselves in the while for the first time. Do I use this? Comes into the scene, an unconditional malloc. If it would be under a condition, if blah 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 blah, then I would have to analyze those if conditions. But now, unconditionally, I make a malloc, and if I will be able to do the malloc, actually, new has a proper value. So I make a note over here, provided that malloc works. If it doesn't work, what will happen? Malloc will return to me and null, telling me, sorry, I don't have memory. So actually, prior to the usage, which comes to the next, which is in the next line, here right away, here I use the new pointer, I use to go to a place in the memory and to go to a subfield. I should better check in here at this position whether new is null or not. Whether malloc returned me a proper place in the memory. If it's null, I should better stop the reading, issue a warning, etc. Keep this in mind. So here this for me, check new is equal for null, error case. Okay. Then, but if that's not the case, new at the first statement receives a proper value and it is used down over here. There is no trouble on that side. Then we come to start. Start is created over here with garbage content. We go down, no start usage, no start usage, start usage. Start usage on the right hand side of an equation. That means give me the value. And what's the initial value? Garbage. Terrible mistake. Start value, the garbage value is used because start is not initialized. This value becomes at the first side 11 is copied over in here. If you go to the algorithm, the link of the new is pointing at the very top to this one. We fill in the value 11 and now garbage, which should not be garbage but now. So the start EP should have an initialization. New does not need an initialization, as we analyzed it already. Sorry. But start needs an initialization. So start is not okay, and we now fix it. Yes, now it is okay, because it has an initial value of null. And then we return. You have to do this analyze for iterative programming. Many programmers, non-professionals, don't do it. And then you have to go and dig through cases where a linked list does not stop. A linked list raises, when it gets printed, a call dump, a segmentation violation. All are due to this type of uninitialized usages. Okay, now here we have a short break.